Hello, and this is the second of my 5 videos on uh, articles that we've read about physics, and this one has to do with black holes. The title of this article is called Possible Detection of a Black Hole So Big It Should Not Exist. So, about big black holes. Recently, physicists have been discussing reports from the LIGO and the Virgo gravitational wave detectors from a black hole that is apparently so large that it should not physically be possible to exist. Of 22 gravitational waves detected by the LIGO and the Virgo sensors, one seems to have a weight of 100 suns, which crosses a threshold limit that black holes should not be able to cross. According to astrophysicist Chris Belzinski at the Warsaw University in Poland, the black hole of such size cannot form in the usual way. So, black holes form from the contracting cores of dying suns, which is quite explosive. But as a sun is dying, the black hole will form from just its center part right here, which let's make this orange and make this very, very bright. From its center part right here, which is very dense, very hot, and has a lot of gravitational pull to it. So in 1967, 3 physicists at the Hebrew University realized that if the core of a star is too heavy, it will undergo a process called pair instability supernova, a giant explosion that will usually completely annihilate the star. So we'll take our giant star here and let's X this off. If it's too huge, it will just destroy itself in a giant explosion here. Awesome. So pair instability supernova happen when the sun's core, the dying sun's core, grows far too hot during its death. And it grows so hot that light inside of this core that's emitted will spontaneously begin to convert into electron-positron pairs, which means it's converting light into physical matter because it's so hot. And was previously holding the suns together, the dying sun together, is light's radiation pressure. So light actually does create a force when it's either emitted or it hits an object, but usually that force doesn't matter. We can't experience it because it's so minuscule. But coming from an object such as a star or a sun, it's emitting so much light that that pressure is actually pretty large, and it's able to compact the sun here, holding this star together in its early phases of death. There we go. So it's holding it together. So when this pair instability happens, this light emission pressure no longer exists anymore because it's now matter. So I'm going to erase these. And there we go. So since there's nothing that's like pulling, oh, it's the other way around. I'm sorry. It actually happens that it pushes it outwards, stopping it from collapsing on itself. I am sorry. The light, that makes sense. Since light is being emitted, it's being emitted out this way. It actually causes pressure upon the sun in this direction, right here, not that direction. So since the light is being turned into positron and electron pairs right here in the surface, so let's call this little plus, let's call this little minus, plus, little minus here, plus, a little minus. This force right here actually disappears, and since there's no force keeping the sun from pressuring in on itself, it will actually begin to collapse on itself. And the sun's core right here actually begins to shrink at a ridiculous rate. Now, this crushing of this core of the sun actually will increase the temperature because there's more friction as the particles are being further crushed together and further crushed together, and as the temperature increases, there are more of these electron-positron pairs being made, and then as there's more electron-positron pairs being made, it continues to get crushing together, and this cycle continues until the heat gets so intense in here, in the core of the sun, that it actually starts to ignite the hydrogen and the oxygen within the sun. So this ignition results in a huge explosion, much larger than anything we know, and it would be called a supernova. This explosion, if it's in small stars, say about 50,000 to 65,000 solar masses, is not enough to completely obliterate the sun, but seems we shrunk. It's not enough to completely obliterate the sun, but it's enough to get rid of some of this matter right here. And in a series of explosions, it will continue to shed matter until it's no longer hot enough to create this continuing run-on effect of electron-positron creation and shrinking, and it will then collapse into a black hole, now that it's below the threshold of causing a huge explosion and being unable to collapse on itself. And from this core, we then create our black hole. But the situation changes when the solar mass is between 65,000 and 130,000 stellar masses. At this point, at this size, it's so huge. The collapse of the sun on itself is so fast, so huge, and so hot that it continues to keep trapping itself, continues to keep crushing itself until the explosion that is generated is so huge that instead of just shedding some mass, it actually just completely obliterates itself. So from here, between the 65 and 130,000 solar masses, no black hole is formed. There's just an extremely huge supernova. And this is why having that 100,000, not 100,000, that 100 solar mass black hole being discovered is very odd. Because usually in the normal process of a black hole being created, if it's in this 100 solar mass range, it would fall in the 65 to 130 solar mass range, and it should normally just completely destroy itself. However, there was one discovered, meaning that there's a different roundabout way of being created. Now, this 50 to 65 solar mass and 65 to 130 solar mass range only applies to black holes or solar sizes that are below 300 solar masses. So this effect only applies, this effect right here, the positron-electron pair conversion and the pair instability supernova, it only occurs below this size, because what happens in this scenario is that when the positron-electron pairs start forming, the collapse is so fast and has so much force that when that when the oxygen and hydrogen finally gets ignited and everything turns on fire, it's not enough to stop this shrink because of the amount of force of this collapse. So it will then just continue to collapse on itself, forming a very large black hole that would be above 300 solar masses. So the title of this article, Black Hole That Is So Huge It Shouldn't Exist, isn't exactly correct because there are black holes that can be bigger. It's just there can't be medium-sized black holes. And for the second type of black hole that escapes this here rule of the pair instability supernova would be the ridiculously sized black holes at the center of galaxies. The article says that we shouldn't need to worry about these and their creation because we don't actually know how they're created. But these extremely huge black holes hold multiple millions to multiple billions of solar masses, and we're unsure of how they're created. All we know is that they're extremely ancient and seem to have been around since the start of the universe. But going back to our 100 solar mass black hole that was recently discovered by the LIGO and the Virgo gravitational sensors, it seems that scientists have discovered that there are roundabout ways of creating black holes that are not from pair instability supernova or from stars collapsing on each other. Now, normally when a star collapses into a black hole, it's generally comes from stars that are just out in space. They're mostly lone stars out here, and they have a little pair with them. The LIGO and the Virgo gravitational wave detectors can actually only detect collisions between two super huge gravitational objects. So these collisions are actually coming from black holes colliding with partner stars in the sky. So these stars are usually very far apart from each other, and this is where the majority of black holes are created and how the majority of stars are formed. But there are some pockets in the galaxy in which stars, matter, and black holes are actually super dense. So there's gas clouds over here. We've got a lot of stars very close to each other. We may have some very huge chunks of matter. And in these huge dense clouds of matter, when a star collapses into a black hole, it's not alone in there. So in this gas cloud, the black hole will actually eat a lot of this matter and will continue to grow in mass as it absorbs a lot of this matter. So this black hole, the 100 size black hole, actually most likely started out as a normal black hole in here, a 50 to 65 solar mass black hole, star that collapsed into a black hole. And when flying around in this super large cloud of gas, it actually collided with other black holes as they swung around in their own gravity, flying around until a collision happened. And that's what we would find from the LIGO and Virgo gravitational sensors. These two black holes merged and then formed our 100 stellar mass black hole here. So this was an observation that scientists are still pretty excited to see because before this 100 stellar mass black hole was created in 2017 many scientists said that it was just impossible to find these medium-sized black holes. They're not super huge, as I've stated before. There are multiple black holes larger than 300 stellar masses or multiple billion stellar masses, but there seemed to be a drop-off in space in which there was just no medium-sized black holes between 130 stellar masses and 300 stellar masses. But this was discovered and proven wrong, which is kind of interesting. So there are other possible theories, however, this seems to be the most common theory and most widely accepted. The other theories being that what if in these pairs of stars, one star here collapsed into a black hole, and then as they continue orbiting around each other, going around in their gravity, this black hole begins to feed off of this star's mass, inducing this star to also collapse into a black hole. And upon this star's collapse into a black hole, they're weaving around in their own gravity until they eventually merge. And this could be another possible explanation for this 100 stellar mass black hole that we found, but it seems that this cloud of mass and black holes flying around seems to be the most plausible and the most accepted so far. So what I want to know is, from this article, is how we haven't actually discovered these before. These sensors and these these telescopes and these gravitational sensors have been around for a very long time. And is it just that we had other pressing matters to look at before finding these black holes, which is very plausible, like I'd understand that? Or is it because it's so rare that only one has come into our radar? So that's something I would like to know. And I would also like to know if would our solar system be part of one of these pairs, or would it be maybe close to other star pairs, and could this possibly happen maybe billions of years in the future to our sun? So thank you very much for watching, and that's about it for my second video.